A 10-2 homework question. Oh yeah, that's nice, Raphael. I gotta give me one of these. All right, so it says match the solution with the differential equation. And they give you a left side, they give you a right side. So I gotta write here for a minute. So they say A is dy dx, there's your dy dx, Justin, is y over x. B is dy dx equals 3y over x, or you could say 3y over x. C, dy dx equals 3x. D, dy dx equals y. E, dy dx equals 3y. So as you can see, those are all my differential equations. And then on this side, they give the solutions, and what you're supposed to do is match them. Which one goes with which one. And so I have y equals x cubed. Y equals 3x. Y equals e to the 3x. 4y equals 3e to the x. And then 5y equals x. So some of you can just look at it and figure it out, but this is how I would approach this. Basically what you're doing is you're seeing if I take the derivative of these over here. So let's just stop right there. Let's just do it. Let's take these derivatives. What's this first one's derivative?
3x squared.
I'm sorry I wrote y prime. I don't know why I did.
Wait, this is third.
Yeah, and what's the next one?
3.
What's the next one?
E3x over 3. E to the 3x over 3. No, 3 he did.
No, 3.
3.
Oh yeah. What's the next one?
3.
What's the last one?
1.
All right, so kind of separated there. I think the hard part's going to be able to see all this stuff at once. So what I would probably do with something like this is I would look at this first one up here, which was y prime equals 3x squared. And I'm going to just tell you what the answer is, but you'd probably have to go through these one by one. And I'm going to say that what if this is the answer? So basically I'm doing that is this a solution type deal. Probably shouldn't have used the y prime, but so basically what I'm doing is where you see dy dx is y prime, and so I would plug this in. Then the only different thing I would do is where I see y, I would plug in my value for y. So let me rewrite, I'm doing this one, which is y equals x cubed, and so I'm picking b. And I'm saying that 3y over x equals 3x squared. So again, see everything that I did here. I said that this is my derivative. That's my 3x squared. Sorry, I just switched it around. And then this is my differential equation. So then the next thing I do is where I see this value of y, I plug this in. And so if I do that, I'm going to have 3x cubed over x equals 3x squared. And are those equal? Yeah. So this is the technique I would use to do this. Now, I will tell you, you already know how crazy Wiley is. Every one of these are not going to be an answer. Okay, or I guess I should say these over here. They actually had one that was two of the same answer. So let's, just to make sure you have this, let's do one more. Do it in this box here. Let's do the next one down. So y prime equals 3. I probably could look at this one pretty quickly and say, I bet it's going to be that one. Because if I write my derivative, so my derivative in this case, so y equals dy dx. If I plug my value of y in, where is my y? What line am I on? If I plug my value of y in, I get 3x. if I plug my value of my derivative in, I get 3. Are those equal? You're saying yes? Why are you saying they're equal?
Oh, I plugged it in a different one here.
Yes. Which one'd you plug? Which one'd you pick?
I picked
Which one?
A.
Okay, so when you plug in this value, in other words, sorry, there's no way you're going to be able to see it. I will rewrite it. It's just I can't get it to fit in there. So if I have y prime equals 3, and I started to call you Olivia. I have a niece called Olivia. Okay, yeah, that's your new name now. So Olivia, oh, we got Tori, we got all these new people in class. In other words, she plugged this value in, and if you just, I'm telling you, this is a flaw, Raphael. I don't like that. That doesn't stay on very well. If I just simply take this and solve this for y, I get my original equation, which was way, way up there, which was y equals 3x. Okay, so probably what I would do to do these, I mean, these are good practice. Basically what they're saying is this a solution to that? Is this a solution to that? And I know once you get an answer, you would probably stop, but you want a way to study for your test. That would be a good way to study, is you check each one of those. Amber, are you okay?
I have a question. Are you supposed to plug in the original function or the derivative into the y?
So if in this one, where is my thing? I didn't have to actually do that. I didn't have to plug in my original function because all I had to do was this one, I could just solve it for y, and I got my original function back. But what you're asking, certainly, I could have went back and done that and then solved that 3x equals 3x. In other words, I kind of skipped that step, right? And you really shouldn't because you should see if those are equal. Somebody over here had a hand? No? You're stretching? You're stretching? You're stretching? Okay, no questions. Good. Yes, Ben.
Is there a solution for 3x or no?
On this one that I'm doing right now?
On
No.
the left side was C.
That's the one, oh, on the left side, C. No. So you ruined it for everybody. Yeah. So in other words, you could look at those, right, and kind of see, yeah. And I think once you kind of get the pattern, you can just look at these and see. You could have done this stuff here kind of in your head. Okay? And it just takes doing many of these. All right, so that is, we're up to 9:30. No, we're not leaving yet. Don't be packing up. Oh, man. So that's 10 to homework.